Hi, my name is Anubhav and I'm Technical Marketing Engineer at Cisco Systems working for Security Business Unit. In this video, I would be showcasing Cisco ASAv insertion using APIC Controller. Before I begin this presentation, let me share agenda with you. I'll start this video with Cisco ASAv Security Solution Overview, where I would be talking about all the devices, security devices supported with Cisco ACI. Then I'll move on to next topic, device package and insertion models, where I will be talking about what is a device package and what are various insertion models available. And then I will talk about deployment models like routed mode and transparent mode of ASA. And at the end of the video, I would talk about ASAv insertion, where I would be doing a live demo. I would be creating a tenant from scratch and inserting ASAv between two EPGs. Let's begin with our first topic, application-centric infrastructure security solution overview. ACI is an initiative, SDN initiative of Cisco. It is a two-layer architecture, spine and leaf switches. All the leaf switches are connected to all spine switches, and there is a device known as APIC controller, which is responsible for orchestration, provisioning and management of resources within the ACI fabric. When we talk about security solution, we have ASAs that we can insert using APIC controller. So we have hardware flavor of ASA. We have virtual appliance of ASA as well. So if you want to insert, if you want to provide security services to any of your tenant, then you can use 5500X series ASA boxes or 5585 boxes, or if you are working on the virtual appliance, then you can use ASAv30, ASAv5 and ASAv10. And for next generation IPS functionality, you can always connect a firepower physical appliance or a virtual NG IPS as well. And this feature is also available if you're using a hardware device also. You can always forward your traffic to built-in firepower module. When you talk about next generation capability, then there is another device that you need to use, because APIC controller will not talk directly to firepower devices or firepower sensors. It will talk to Firesite Management Console, and Firesite Management Console will push policies to sensors. But in case of ASAs, APIC controller has capability to talk to ASAs directly. So in order to integrate these devices with APIC controller, we need a device package. So what is a device package? It is nothing but a zip file which contains the device specification. Along with that, it contains Python script written by the device vendor. In this case, Cisco Security BU has written device package for ASA and for firepower as well. It provides interface between APIC controller and device. So whenever any configuration orchestration has to be done or any configuration changes are required, users or administrator can make changes directly to APIC controller, and APIC controller will use device package and push this configuration to the device. So next topic is ACI security insertion model. On left hand side, we have ASA physical box. So APIC controller has capability of talking directly to ASA using a device package, And then if you're using the latest device package, you can always forward the traffic to the firepower module as well. But in case if you're using a physical hardware appliance, firepower appliance, APIC controller has a device package which lets you talk directly to Firesite Management Console, and Firesite Management Console will provision policies and configuration on the physical appliances. So since this video is on insertion of ASAv, so I have created one slide just to give you an idea about Cisco ASAv appliance. It is a virtual form factor of a well-known firewall ASA. It is based on the open architecture where we have support for multi-hypervisor, multi-virtual switches. We have flavor of ASA that you can bring up in public clouds like Amazon. And then we support open APIs. We have API plugin for ASAv that you can install on top of ASAv, and then use third-party API tools for managing and orchestrating configuration. We do have smart licensing available for ASAv. We have perpetual license as well as license as well as the permanent license available for ASAv. Now let's talk about deployment models. When I talk about deployment models of ASAv, we have routed mode, wherein we can place this device between two EPGs and can have our next hop configured as the firewall, and firewall will do routing between the two EPGs. And we also have transparent mode available, wherein this device will act as a bridge between the two endpoint groups. So with new device package that is available now, device package 1.2 or higher, we now have capability of having multiple subnets or multiple subnets within single EPG. If you look at this diagram here, on left hand side we have EPG Corp, and on the right hand side we have EPG Web. So if I talk about EPG Corp, presently it has three subnets. So now if I want to add another subnet, that is now possible, because VRF of the subnet would be created on the leaf switch directly on the ACI fabric, and ASA will have a routing neighborship between ACI fabric and firewall. So you can now have multiple subnets within one EPG. Cisco ASAv service graph demo. So before I jump into demo, let me show you this diagram, and let me tell you what exactly I'm going to do in this demo. I'll start this demo with creation of a tenant, and under the tenant I would be creating two EPGs, EPG app and EPG web. Under each EPG, I would be adding one Linux box. Linux 1 would be placed in app EPG, and Linux 2 server would be placed in web EPG. Now using APIC controller and device package, I would be inserting ASAv between these two EPGs, and will configure ASAv in routing mode so that any traffic coming from app to web is routed via ASAv, and I'll control security policy on ASAv. So before we integrate APIC controller with ASAv, we need a device package from cisco.com, and we need to import this device package onto APIC controller so that it can integrate with ASA or ASAv. So in order to download this package, go to cisco.com, log in with CCO ID, Go to Product, Security, Firewalls, ASA. Under ASA, select ASAv, and under ASAv, select ASA for ACI device package, and it is suggested to download latest version of device package. I have already downloaded this device package on my computer, so I'll straight away go to APIC controller, and under APIC controller I'll first log into APIC controller, and this is dashboard of the APIC controller. From here I need to start my demo. So first of all, I'll go ahead and import downloaded software onto APIC controller. I'll first go to L4 to L7 services, and then I will select packages. Under packages, I'll just right click on this and click on import. I'll browse to the file. This is my downloaded file, and I'll click on submit. So it is now importing device package which we downloaded earlier. Device package is successfully downloaded, and we now have version 1.2 available, and minor version is 4.8. Next step is to create tenant from scratch and build our network. So before I begin creating a tenant, let me show you this network, show you network diagram. So I'm planning to create this network. So when I talk about this network, I would be creating tenant X initially, and under tenant X I would be creating EPG app and EPG web. So let's begin with our creation of tenant. So I'll go to tenant, click on add tenant. I'll name it as tenant X. Under tenant X, I'll just click on this plus sign to create a security domain. I'll just type tenant X security domain. Click on submit. From this list, I need to look for tenant X. I'll select it and click on submit. With this step, I have created new tenant in our ACI fabric. So any configuration changes that I'll do here will not impact any other tenant in the network. Once we have tenant created, I'll start with creation of VRF. So I'll dedicate one VRF to this tenant. So I'll name it as VRF tenant X. I need to provide bridge domain. So let me go back to my diagram again. In this diagram, I would be creating EPG app and EPG web. So I will create two bridge domains. One would be web. I'll create another bridge domain. Name it as app and put it in the same VRF. So till this point, what I've done is I've created two bridge domains and placed them in single VRF, and that VRF is dedicated to tenant X. So after this, I would be creating application profile. So I'll name it as APIC Tenant X. Here I need to specify endpoint groups, so create endpoint groups. I'll create first endpoint group as web, and here I will select broadcast or bridge domain as web, and I already have my VMM domain created. So when I integrate my APIC controller with VMware setup, I create a VMM domain. For virtual integration, it is VMM domain. So I have TME-VC VMM domain already created. I'll map this EPG to this domain. I'll click on update, create another EPG, and that EPG is app EPG. Same thing, I'll select the TME-VC VMM domain. I'll map it to that. I'll click on submit. So we now have three things already configured. We have a dedicated VRF for our tenant, and then we have two bridge domains. We have our application profile also created for tenant X. So we have EPG web and EPG app created already. So next step is to add our ASA. So before I add ASA, let me tell you, I already have um, a functional ASAV running on my vCenter. On that virtual ASA, I have only configured management IP address, nothing else is configured. So in order to add L4 to L7 devices, I'll go to L4 to L7 devices, click on create L4 to L7 devices. Here I will name it as ASAv30. From service type, I will select firewall. Since it is a virtual firewall, I would be selecting virtual. I would be selecting VMM domain. It is on TME-VC single mode. Device package 1.2. Model is ASAV. Go through is transparent and go to is routed mode. So since I'm planning to put this ASA in routed mode, I'll click on go to mode. I have created username Cisco, password Cisco123, and I will add management IP address of the firewall. It is 172.28.198.50. I'll use HTTP, and this is my ASAv30 tenancy. Or let me go to my vCenter and rename this machine. Instead of tenancy, let me rename it to tenant X. Okay, and let me go back to the controller and cancel this, and I'll start from scratch. Let me copy this address here, click on cancel, click on create this again, ASAv30 firewall, VMM domain, single firewall, model ASAV, go through Cisco 123, Cisco 123. Let's do this. Okay. From this, I will select ASAv tenant X. I'll add interfaces gig 0. We need to leave interface adapter 1 because that adapter is mapped to management 0 interface. I'll start from interface 2, gig 0/1, interface 3. So I have selected two interfaces. One will act as the web interface, other will act as app interface. And So let me go to that diagram again. So I'm going to create this ASA. One interface will face towards app EPG, the other one will face towards web EPG. Okay, let me go back to this cluster IP. This is the management IP of ASA. So my ASA has 10.0.0.0.50 address, and this is the translated address, so I'm using the translated address. And under cluster I need to provide provider and consumer interface. So my consumer interface is the web interface, so any traffic coming from web is a consumer in this case. And let me add another interface as producer interface. So producer interface is app interface. So I'll click on next and I'll click on finish. So I have now added my L7, L3, L4 to L7 devices, and if you look at the status of the device, it is stable. So my APIC controller can now reach ASAV. We have successfully added ASAV, and now APIC controller is talking to ASAV at the moment and device status is stable. So our next step is to insert this ASAV between app and web EPG. So in order to do that, I'll go to application profiles. I will select tenant X application profile. I'll drag this contract from here and drop it. So I need to place this ASA between web and app. So web is my external interface or the consumer interface, and app is my provider interface. Contract is required in order to allow communication between two EPGs. So I'll create a contract, new contract. I'll name it as web to app. I will also create a service graph. This service graph will help us stitching our ASAV in the contract. I'll name this service graph as SG ASAV30. I'll drag my previously added managed ASAV30, name it as ASAV30, ASAV30. I'll select it as routed mode. From this profile, I will select routed mode profile. I'll leave other options as default. Click on next. On this screen, it is very important to pay attention, because if you will not add correct parameters here, your configuration will fail. So I will click on all parameters and I'll go to access list first. I'll expand this access list, click on add new one. For now I will allow permit IP. I'll extend this. Action is permit. Order, I will use any random number. I'll say 10. Now I will go to interfaces. Under interfaces, I will first configure external interface. So external interface, I will expand interface specific configuration. I will select IPv4 address. So I will mention 200.1 address. Let me show you that diagram again. Web is my external and app is internal. So 200.1 is on the external interface and the internal interface will be 100.1. 200.1/24. I'll click on update. I will now configure internal interface. On internal interface, I will assign 192.168.100.1/24. And before I click OK, let me show you ASAv for now. This is my vCenter. On my vCenter I have already added ASAv 30 for tenant X. So let me open console and let me do show IP here real quick. So presently only management IP address is assigned. We have APIC controller talking to ASAv, and we have not pushed any configuration as of now. And if you look at the port profiles here, these port profiles are the profiles which are not placed in any specific application EPG. So what I will do is now I will go back to my application controller and click on OK on this page, and then I will click on submit. So with this submit, I think my configuration should be pushed already. I will go ahead and go back to that ASA again, and this time here I will type show IP. Okay, now I have configuration, show access list. Yes, we have ACL also. Remember we added permit IP any here. And now let me go back and check the port profiles again. See, APIC controller automatically provisioned these application port profile for me and added the required profile on the required interface. Network 1 is for management, so management remained in the management subnet. The other one is gig 0 interface, it is now web interface, and gig 1 interface is now app interface. So with this we have already pushed configuration, moved ASA interfaces to required port profiles. I will go ahead and put my machines, my Linux machine in tenant X application profile. Yeah, it is already there. The other one also, let me verify. Yeah, it is also in the correct application port profile. This we have seen that ASAv is now stitched between web and app APG. APIC controller was able to talk to ASAv and push configuration. So we are now at the point where we can log into our boxes and initiate a couple of pings to verify connectivity. So let's go ahead and log into jump box. I will log into Linux 1, Linux 2 and APIC controller, as well as ASAv. I'll show you the entire connectivity. Before we verify connectivity, let me log into APIC controller and show you where exactly we need to look for any error or faults. So start with the application profile and go to fault. Make sure that there is no fault seen here. Then move on to your application EPGs. Look for faults here. No faults should be here. Look for faults here as well on the other EPG. Then go to bridge domain. On the bridge domain, make sure that L2 unicast, L2 unknown unicast is set to flood, and make sure that faults are not seen here as well. Again, flooding is enabled here. No fault is seen here. Then go to L4 to L7 devices. Make sure no fault is seen here. Go to device selection policy, check for faults. No fault should be seen here. and deployed graph instance. So our configuration looks pretty fine. There is no fault or error seen on APIC side. Now let's go to jump box and log into ASA once again. On this ASA I have IP address 192.168.201 assigned to external interface and 100.1 is assigned to internal interface. So let me refer back to that network diagram again. So this is our diagram of 200.0/24 is web and 100.0/24 is app, and ASAV is provisioned between the two EPGs and traffic is getting routed via ASAV. So let's go back to our device. So let me see if I can ping from our ASA. Let me see if I can ping my Linux 1 box 192.168.100.50, and the other box is 192.168.200.50. So both devices are pingable. Let me do show ARP. We can see ARP entries for that as well. Let me do show access list. I have allowed everything from external interface to internal. Show name if. External is security level 50 and internal is security level 100. Let me now log into one of the Linux machines, the next one. ifconfig. It is 100.50. Let me ping 192.168.100.1. I can reach ASA. Let me log into the other Linux also. Ping 192.168.200.1. I can reach ASA from there as well. So now it's time for me to ping through the ASA box 192.168.200.50. This IP address is located across the ASA. I'll place a continuous ping from here. I'm getting responses. Let me go back to ASA and type debug ICMP trace. So traffic is coming from external interface and it is hitting internal interface. Let me initiate ping from other side. Ping 192.168.100.50. I can see replies coming back. Debug ICMP trace on all. Yes, traffic is from internal going to external. So our connectivity is through the ASA box. So let me recap what we did in this video. We started this video with creating tenant from scratch. We created VRF for the tenant, then we created bridge domains, then created EPG, added ASAV, integrated or enabled communication between APIC controller and ASAV, and then we created a service graph to stitch ASAV between web and app EPG, and we enabled communication from app to web and vice versa. I hope you enjoyed this video and thank you for watching.